So guys, this was the problem we were discussing. So we need to find the acceleration in that case in 5 seconds. Okay, so acceleration is change in velocity. So thereby v2 v1 magnitude was 10 meter per second. Okay, so I told you to solve that by triangle law of vector addition. Actually acceleration was nothing but v2 minus v1, change in velocity upon time. So v2 minus v1, v3 is actually more equivalent to negative of v1. Okay, we had discussed that. Please watch the previous video. So here it follows we use the triangle law of vector addition. So this would actually represent the resultant of v2 minus v1. Okay, the resultant of these two vectors, and this is a hypotenuse for that matter. So what would be the magnitude here? If this is a hypotenuse, so that would be the magnitude of that r resultant would be 10 square. R represent the resultant over here plus 10 square. It's a hypotenuse, so Pythagoras theorem, so 10 root 2. So that is the magnitude of the resultant over here. And if I need to find the acceleration, so that is actually rate of change in velocity, which is 10 root 2, which is resultant vector magnitude divided by 5. If 5 seconds was there, so 2 root 2 is the acceleration here. And moreover, I can also comment over the direction. Say for example, you know this was v2, this was v3, or actually v1, negative of v1. I give another name for v3 to the negative of v1. So this was the resultant, and you know I know resultant is 10 root 2. Even I can know the direction, even I can know this angle. If this is 10, this is 10, this is a right angle triangle, this has to be 45 now. So I know everything about this vector and acceleration. Okay, so we'll move ahead and discuss some more things. So the next thing is here is, now we have discussed graphical method to for vector addition, and in that we had discussed the first one was the triangle of vector addition. The second one for the graphical is like parallelogram law of vector addition. Second is the parallelogram law of vector addition of addition. Okay, and what does that represent? That actually says if there are two vectors, okay, and they are like represented by these two arrows such that their tails are joining, and this would be the angle between the vectors. We call this as the angle between the vectors. Angle between the vectors, I told you, is the angle between their tails. Okay, then you complete this parallelogram. You just complete this parallelogram in this way. So this is a vector A, say for example, and this is another vector B. Okay, and you need to add those vector A plus vector B. You need to add those vectors. So you just need to represent them by the two sides of a parallelogram, enclose it and make it a parallelogram. Then their resultant would be represented by the diagonal of the parallelogram. So actually I make this as the whole line, and it represents the resultant of A plus B. So the resultant is represented by the diagonal. Okay, so the addition of two vectors will be represented by the diagonal of the parallelogram. Okay, we'll discuss more about into it, and I just need to give you a brief intro about the next law, which is the Polygon law of vector addition. So that Of course these are also triangle, and parallelogram are also polygon. So the last is the polygon law of vector addition. Law of vector addition. Okay, don't worry about the parallelogram law of vector addition. This is the next thing we just need to do is the mathematics. Okay, you just need to know how to find the diagonal of a parallelogram. If you know, then it is good, and if you don't know, then I'll give you the formula after this. Okay, don't worry, we'll discuss that. Parallelogram, polygon law of vector. Okay, so what does this represent? Actually this is the entirely similar like the triangle law of vector addition. So it's like that if there are vectors and you need to add them. Actually this is for addition, vector addition is your adding. It sounds like addition from my mouth. Don't worry about that. So there is one vector. Say for example there is one vector, then there is another vector, then there is another vector, then there is another vector. You just need to join vector from head to tail, from head to tail, from head to tail. Then the resultant of these all vector, say for example vector A, vector B, vector C, vector D, you just need to attach them like from tail to head, from tail to head, head of one, tail to another, head of one, tail to tail of another. So the resultant of these vector would be in the opposite sense of their sense. The sense in which these vectors are rotating or going, you have to, the resultant would go in the opposite sense. So their sense is like anti-clockwise. If you need to form another vector, it would go like this now, but the resultant would actually go like opposite to the sense there, tail of this, head of this. So this would represent their resultant, not that. Okay, this is the polygon law of vector addition. It's not important, just I just need to give you an intro of that. The rest is if you know, you should know the how to just use it. So what would the resultant magnitude, the length of this vector, and direction, you can know that. Okay, so this was about the polygon law of vector addition. So now let's go about the another method for vector addition, and we call this analytical method. First one was the graphical one, now is the analytical. Excuse me, is T. Analytical, don't go about the spelling. Analytical method. So it's actually, I'm giving you the formula, nothing, just giving you the formula. So analytical method of vector addition, for that I'll need to jump to the parallelogram law of vector addition. So for in analytical method, what I'll do is, if you are having two vectors, okay, say for example vector A and vector B, and the angle between them is theta. Vector A and vector B, and angle between them is theta. So if I need to add these vectors A plus B, okay, concentrate. So I would make a full parallelogram here. Okay, then the diagonal represent the addition of these two vectors, the diagonal, and that would be this would be the diagonal. So this would represent the resultant of vector A plus vector B. Okay, this is the diagonal, and this represent the addition of vector A and vector B. Now I need to find what is R. Actually, what is R? Magnitude, direction, everything, angle and all. So what I do, I drop a perpendicular over here. Okay, so this is theta, this angle would be theta, parallelogram. Okay, so this is a parallelogram, this is A, this would also be A. Okay, A means in the magnitude, and this would become, thereby this would become A cos theta, and this would become A sin theta. You know that. Okay, that triangle, in that triangle I'm saying this is A sin theta, I'm saying this is A cos theta. Now see the whole triangle. Shall I name it? Okay, P, Q, R, S and T. So in triangle, in right angle triangle, RTP, you can see that I can apply Pythagoras theorem, because you know it's a right angle triangle. Okay, so if I apply that, so you know that A R square, which is the resultant, which is the diagonal also, which is the hypotenuse over here also, would be equivalent to, excuse me, A square sine square theta, P square perpendicular square, and the base 1 is important. Base is consisting here of two things. That's why I'm erasing it to actually demonstrate to you very more clearly. And which is, base is B plus A cos theta whole square. So this is one. Now let's talk over this. This would become, excuse me, R square A square sine square. You can put this together. Okay, then B square, you can open this bracket as well, and plus 2AB cos theta. So eventually the magnitude of the resultant vector would become A square plus B square, and that is actually magnitude. Okay, plus 2AB magnitude of A mod, this is mod A mod B mod cos theta. So this would give you the magnitude mod of resultant vector. And if I need to bother about the angle which the resultant vector makes, okay, so this you need to remember always, though it is more about mathematics. And if I need to actually bother about what does the angle, what is the angle which the resultant vector makes with the any vector to actually determine its direction, so we can easily define that. See, this is the, make it a parallelogram, so this is R, this is A, this is B. I think it was the, or other way around, that doesn't matter. These are just the variables, don't worry about. But as if taken this as B and this is A, don't cram it. Okay, just try to understand. So what is the angle the resultant makes with the vector B is alpha. Theta was the angle between the two vectors, and alpha is the angle which this resultant vector makes with B vector. Similarly, I can find the angle which R makes with A vector. Is not a rocket science. So it would be, I can find it that tan alpha would be equivalent to, see, this was A, so this was A, this would be A cos theta, as it was theta, it was theta, the angle between the two vectors, and this would be A sin theta. So tan alpha would be equivalent to A sin theta over B plus A cos theta. So this is how I can find the angle resultant vector, what angle the resultant vector makes with the B vector. Okay, so now we'll do some problems over it.